Hi guys. So today we are going to look at solving problems. So problem solving when problem solving with algebraic models. So what we have done so far, we have looked at different equations. We have looked at how to graph and how to find the line of best fit. We've looked at linear, quadratic, and we looked at exponential. We also looked at how to simplify exponential equations and how to solve for these exponential equations. So today we're going to kind of like put it all together. All right. So let's look at the first example here. And the first example says, consider the formula for compound interest A equals P bracket 1 plus I to the power of n. If you're looking at this equation, there's four variables. So you have the A, the P, the I, and the N. A is the final amount. So A is the amount of money that you will have after a certain period of time if you're collecting a certain amount of interest. P is your principal. So P is the principal. So this is the amount of money that you put in initially into the account. So let's say you have $1,000, you put it in the account, that's your P, that's $1,000. I is the interest rate. Something that you have to be careful here with, that I is always in decimal. So that means if they give you like 8% interest rate, that's 0.08. So you divide the 8 by 100 because that's what percentage means. And N is the amount of time you left it in the bank. So now there's too many variables there. Usually there won't be that many. Usually they will give us 2, we'll have 2 because you remember in any equation you have y and x, right? But in this case, it's not going to be y and x. It's going to be 2 letters, A, B, I, and whatever. Now, and then depending on what they give us, we're going to have a different kind of equation. So we might have a linear equation, or we might have a quadratic or exponential or whatever. So let's look at these examples. So the first example says, suppose that we have I and we have N. So they give me the I and they give me the N. And I is 0.08 and N is 10. So I'm going to end up with an equation that looks like this. So A equals P 1.08 to the power of 10. 1.08 to the power of 10 if I put that in the calculator. So remember that just the 1.08 is the power of 10. That's why there is the bracket. So if I put that in the calculator, that's going to give me 2.1589, whatever, right? So that's the same thing as writing y equals 2.159 times p, right? So if I'm looking at this, this is a linear equation. Why is it linear? Because as you can see, the exponent on the a is 1, the exponent on the p is 1, so everything has a degree of 1. That means that's a linear function. Good. Now, however, if they give you P is 1,000 and I is 0.08, okay? So you're replacing P with 1,000 and you're replacing I with 0.08. So you're gonna end up with an equation that looks like this. A equals 1,000 and then 1 plus 0.08. Let me write that down. 1 plus 0.08 to the power of n. So that's gonna give you A equals 1,000 and then 1.08 to the power of n. So if I'm looking at this equation, the exponent is the variable. And we know from grade 11 that when my exponent is a variable, I have an exponential function, right? So this is going to give you an exponential function. Now, another simple example here. So if they give you, we're still dealing with the same equation, right? So if they give you P as 1,000 and N as 2, okay? So you're replacing P with 1,000 and N with a 2. So in this case, I have A equals to 1,000, 1 plus I to the power of 2. Anything exponent 2, what do we call that? Quadratic, right? So because this is a degree 2, we call this a quadratic equation. So now solving for whatever variable, right? So whatever variable I have left in these equations. So let's say if in the first equation I have A and P, right? So if they give you A, you can solve for P, or if they give you P, you can solve for A. In the second equation, you have A and N, right? If they give you N, you can solve for A. If they give you A, you have to solve for N. And they have different techniques. We have different ways to solve for all of this. And in the third equation, if they give you I, you can solve for A. Or if they give you A, you have to solve for I. So we're gonna look at how to do that, okay, in the next examples. So let's see. The first example. So in the equation, A equals P, and then bracket 1.08 to the power of 10, solve for P if A is equal to 1,000. So in this case, they give you A equals to 1,000, and they want you to solve for P. All right, so first thing you're gonna do is you're gonna replace A with 1,000. So that's gonna be 1,000 equals P, and then 1.08 to the power of 10. Now, remember that when you have the bracket here, that means this is a multiplication. In order for you to isolate for P, always really want to isolate for that variable, you're going to have to do opposite operation. And the opposite operation of multiplication is division. So what I have to do here is I have to bring this whole thing to the other side as a division. So that's going to be 1,000 divided by 1.08 to the power of 10. And that would give me P. And if I do that on the calculator, right? So I can do 1,000 divided by 1.08 to the power of 10, and that's going to give me 463.1934, whatever. Because this is money, principal is money, amount is money, I have to leave it to 2 decimal place, so I'm going to end up with $463.19. All right, so you always have to ask yourself, what's happening between the number and the letter that you want to isolate for? What kind of operation do I have? Now, given A equals 1,000 times 1.08 to the power of n, solve for n if A is equal to 3,000. All right, so what I have here is I have that 3,000 is equal to this whole thing. Now, I don't know what n is, and I need to solve for that. I can sit down and do guess and check, right? So we can sit down and do guess and check and try different numbers for n until I get the answer. This might take a long time. So if you remember from the activity 7, you're gonna have to use Desmos or use one of your technologies to actually graph for this. So what we're gonna graph for, the equation, which is 1,000, 1.08 to the power of n. And then we're gonna graph when y is equal to 3,000 or a is equal to 3,000, and then we're gonna look for the point of intersection. All right, so if I have here, so I'm gonna go to Desmos. And then we're gonna graph the first equation, which is y equals 1,000, or a equals, let's keep it, a equals to 1,000, and then 1.08 to the power of n. And then the second equation is when a is equal to 3,000. So remember that these are the two things that they've given you. They give you the equation and they give you the a is equal to 3,000. Obviously, you're not going to see the graph here because that's a pretty 1,000 is high. So what we have to do, we have to zoom out as much as possible. And now you see it. You see some of it. But again, because this is the y right now, they're only like 800, 600, right? So you want to kind of change your settings a little bit. And then you want to go for the x-axis from, let's say, 0 to, 100 or to whatever, 50, let's say. And then on the y-axis, you want to go from 0 to 4,000, if we can fit that. There you go. All right. Now I should see a equal to 3,000 here. Okay, let's call this y, and let's call this y. All right, the reason why, because the decimal sometimes I don't understand what A is, so they use Y. It doesn't matter what letter you use, it's the same thing. So we see here that I see that point, that like point of where the two graphs meet, where the line and the graph meet, and that would be when n, if I'm looking for n, that's your x value. So after 14 years or 14.2 years, you're gonna get 3,000. Okay, so when you graph this, so if you see this here, this point here, this point here, right? That's going to be 14. So x is equal to 14.27. You see it here. All right. So in this case, I had to graph to solve for n. Otherwise, I'm going to sit down and try different variables, right? So I can try n equals 10, n equals to 20, n equals, and then I'm going to see that, no, this is too big. And then I'm going to have to try in between until I get to that 14.27. So we call that guess and check. All right. Now, let's look at the third example. So using the equation a equals 1,000, 1 plus I squared to the power of 2, solve for I if a is equal to 1150. All right, so let me just scroll this up a little bit. So they're asking me to solve for I if a is equal to 1150. So I know that I'm going to replace a with 1150, and I'm going to have to solve for I. So that means you're going to have to isolate for that I. And to isolate for that I, you're going to have to get rid of everything else, but there is an order. As we do with BEDMAS, we have an order. When we're collecting terms together, when we're isolating the terms, there is an order. And the order is reverse BEDMAS. So when you're getting rid of the terms or the numbers, you're gonna get rid of them in the reverse order. Okay, so the last thing you're gonna get rid of is whatever is in the bracket, and the last thing you're gonna get rid of is the exponent, and then division, multiplication, and addition, subtraction. So if I have an addition or subtraction here, I have to get rid of that first. But because I don't have that addition or subtraction here, that means I'm gonna have to skip to the multiplication or division. So in this case, I have this multiplication here. I have 1,000 multiplied by this whole bracket. So I have to get rid of that. I have to bring it over as a division. So that's going to be 1150 divided by 1,000 equals to 1 plus I to the power of 2. So if I find the answer for this, that's going to be 1.15 equals to 1 plus I to the power of 2. Then comes the exponent. So I have to get rid of the exponent. What's the opposite of square? So the opposite of square is square root, okay? Or what we learned, you can take the power of 1 over 2, right? Because we talked about that square root and the power of 1 over 2, right? And the power of 1 over 2, they're exactly the same thing. One is written in radical form, one is written in fraction form. So what I have here, what I have to do here is I have to take the square root of both sides, and then the square root, get rid of the square. So you'll end up with square root of 1.15 equals to 1 plus I. So the square root of 1.15 is 1.0724, and then that's equal to 1 plus I. All right, now I want to isolate for I, so that means I have to bring the I over, and that's going to be a subtraction. So that's going to be 1.0724 subtract 1 equals to I, which is going to give you 0.724 equals to I. And now I have the I, and the I is in percentage 7.24%. That would be by multiplying this by 100, and that will give you the percentage. All right. So this is going to take some practice, right? Take some practice to actually solve for the I, right? This is probably one of the hardest one of them. So in this question, they're asking you to solve for x to 3 decimal places if you have x to the power of 5 equals to 100. We are doing, remember, opposite operation, okay? So if I have x to the power of 5 equals to 100, to get rid of that power of 5, I have to do the fifth root, or I have to do it to the power of 1 over 5. So I'll show you two things. So you can do it this way, where you can do the fifth root of both sides, and that will get rid of the power of 5. Or you can raise it to the power of 1 over 5. Both of them, it's exactly the same thing. It will give you exactly the same answer. Now, how do you do this on the calculator? Depending on your calculator, you're looking for two different things. So if I do this on the calculator, if I do the 100 to the power of 1 over 5, make sure you do the 100, and then you're looking for your power button. It could be like this. It could be something that looks like this, or it could be something that looks like this. So there's different buttons on different calculators, depends on which one you have. If you're not sure, come and send me an email, and I will respond back to you. Take a picture maybe of your calculator and send it to me, and I can point out the different things. So you're gonna do 100 to the power, and make sure that you put the 1 divided by 5 in brackets, okay? And that will give you your answer, which is, if I do 100 to the power of bracket 1 over 5, close bracket, and that's going to give me 2.511. I'm not sure if you can see this on the calculator, right? The light is a little bit weird, but basically that's one way to do it, right? And that's going to give you 2.512. The other way, if you can find on the calculator, if I do it the radical way, if you can find on the calculator a button that looks like this, and then you can put the 5 here, okay? So my calculator has a button that that is like this. So I don't know if you can see that. And then I can enter whatever number I want in here. So that's going to be the 5th, right? So I'm going to enter a 5 here, and then I'm going to have to move my cursor so I can enter the 100. And that would be the 5th root of 100, and I'm going to get exactly the same answer. So I'm not sure which calculator you have and what works better for you, but both of these, either you do the nth root, so whatever the number is, you do. So let's say if you had, let's say, x to the power of 7 equals to 100, right? What you're gonna do, you're gonna do the 7th root. I can't even write here, so let me just undo here 1 second, and then you're gonna do the 7th root of both sides, right? Whatever that exponent is, or you can raise it to the power of 1 over 7, okay? So the following questions involve formula from a wide variety of application. Try each question on your own before checking the answer. Let's look at these questions. All right, so the first question, the following formula relates to the electric circuit. P equals E squared divided by R. where P is power in watts, E is electromotive force in volts, and R is resistance in ohms. Solve for R if P is equal to 800 and E equals to 120. All right, so what do I have? I have P, which is 800, and I have E, which is 120, and I'm trying to solve for R. There's different ways that you can do this. You can either plug in the numbers in and then isolate, or you can isolate for R first, then plug in the numbers. Doesn't matter which way you do it, whatever you're more comfortable with. Okay, I'm gonna show you if I'm gonna isolate for R first, because that's what I'm looking for, and then plug in my numbers, and I'll show you the other way. I'll show you both ways. Okay, so if I wanna isolate for R, because that's what I'm looking for, what I have here is I have P equals E squared over R. So I want to bring R to this side, and I want to make sure that it's by itself. Because this is a division, in order for me to bring it to this other side, it's going to become a multiplication. So bringing this over here, that's going to become PR equals E squared. But remember, I want R to be by itself. So I need to get rid of P. Now what's happening here is that there is a multiplication between P and R. So what I need to do is I need to bring the P back here. So now R is equal to E squared. The opposite of multiplication is division, so that's going to be E squared over P. So now I isolated for R. I can plug in the values for E and the values for P, and that's going to be R equals E squared, so that's 120 squared over 800. And then on your calculator, you do 120 squared first, because exponent first, and then divide that by 800. And that's going to give you resistance of 18. And remember, because the resistance is in ohms, you're going to have to make sure that you include your units, which is ohms. This is the symbol for ohms, or you can write ohms. Okay. So that's one way you can do this. Another way, you can plug in your values first. So you can do P, which is P is equal to 800 equals to, and then E is 120 squared over R. And you can find 120 squared. So you can do 800 equals to 1,000 or 14,400 divided by R. Then now you're going to isolate for R. So again, same thing. You're going to multiply the R by the 800. And then you're going to bring the 800 over as a division. And then you can do that on the calculator. And then you're going to get 18. So these are different ways to solve. Whatever you're more comfortable with, you can do. Now, the second question is saying that solve for E if P is 1440 and R is 40. So now we're solving for E given P and R. So I'm isolating for E given P and R. So I want E to be by itself. First thing I want to get rid of, because remember, bag mass, backward, right? So the first thing I want to get rid of in this case is the division. So bringing the division over, so it's going to become PR equals to E squared. Now I want E by itself. So I have to get rid of the square. What's the opposite of square? Square root. So get rid of the square by square rooting, and that's going to be the square root of PR equals to E. Now you see that E is by itself. What we have to do, we have to plug in the values for P and R. So I can do 1440 for P times 40, all under the square root, equals to E. And now I can do that on the calculator. Make sure that the 1440 times the 40 are all under the square root, sorry. If you're not 100% sure, put brackets, because both of these are under the square root. So make sure that you show that in the calculator. So 1440 times 40, and that's going to be 240. So the square root of this is 240. E is in volts, so that's going to be 240 V. That's equal to E, and that is my final answer. All right. Now, when you are dealing with word problems such as these, make sure that you include the therefore statement at the end to tell your reader that this is your final answer and this is what you found. All right. Now, let's look at the next question. So the volume of a sphere is given by the formula V equals 4 over 3 pi r cubed. Determine the radius of a sphere having a volume of 2,000 centimeter cubed. So in this case, I know the volume, I'm looking for the radius. All right, so what I have here is I know the volume, I am looking for r. So I have to isolate for the r. So I have V equals 4 over 3 pi and then r cubed. I can do this in like multiple ways, but I'm gonna show you step by step, okay? What do I wanna get rid of first? Because I want r by itself. Usually, in this case, because there is only multiplication and division, I'm gonna get rid of this division first, okay? So I'm gonna bring that 3 over here, and that's gonna be 3V equals 4 pi r cubed. Now, I have 4 times pi times r cubed, and I want r by itself. So I have to bring this over here. So I can bring the 4 pi, because they're multiplied, they're stuck together, they're multiplied. I can bring them both at the same time to the other side. So it's going to be 3V over 4 pi equals to r cubed. Now, you see that r is almost by itself. It has the cube, and I want to get rid of that exponent. How do you get rid of that exponent? What's the opposite of square? Square root. What's the opposite of cube? Cube root, right? Or you can raise it to the power of 1 over 3, which we talked about that previously, right? So I can do the cube root of both sides, or I can do the power of 1/3. It doesn't matter. They're both the same thing. Whatever you're more comfortable with, you can do, right? Now, what happened when I do this, that gets rid of the cube. So you'll be left with cube root of 3V over 4 pi. So what I have here is the cube root of 3 times, they gave me V as 2,000 over 4 pi, and that's equal to the radius. Now, it's important that you know how to put that in the calculator. It depends on what kind of calculator you have, again. Make sure that when you're doing that, your whole 3 and 2,000 divided by the 4 pi is all under the cube root. Or what I suggest that you do, you find each one separately and then you do the cube root. So what I usually tell my students, there's multiple ways. If you know how to use your calculator, you should be familiar with this. If you don't know, make sure that you do the top first. So that's 3 times 2,000, which is 6,000. It's okay to do with multiple steps, better than making a mistake. Do 4 times pi, because this is where a lot of people, if you they make a mistake and then becomes a multiplication and division and whatever, and this is where a lot of final answer mistakes happen. So it's going to be 12.566. Keep as many decimal places as you can. Do the 6,000 divided by this, and then cube root. Okay, but if you know how to do that in one shot, do it in one shot, that's fine. I'm gonna do 6,000 divided by the 12.566, and that's gonna be 7.8, or about 7.8. So determine the radius. It doesn't say to how many decimal place, so we're gonna leave it to 1 decimal place, so that's gonna be 7.8 centimeter is the radius. All right. So isolating is a problem, but then putting it in the calculator is another one. Okay, so be careful, guys, please. If you have any questions, do not hesitate to email me. All right. So let's do this question as well. So we have the perimeter of a running track is given by the formula P equals 2 pi r plus 2L, where r represents the radius of the semicircle and L represents the length of the straight section. Determine the value of r if P is equal to 400 and L is equal to 100. So we're going to try to find r. So the question is, find r. So what is r equal to? Knowing that P is equal to 400 and L is equal to 100. So I know P, I know L, I'm looking for R. So let's put the values in here. So I know that P is equal to 400 equals 2 pi R, I don't know what R is, plus 2 times 100, that's for L. I'm just doing it this way because it might be easier for you guys to do it that way, where you only have one letter that you're isolating for, and you know that you're isolating for that letter. So that's going to be 400 equals to 2 pi r plus 200. Now I'm isolating for r. Remember that when you're isolating, you're following BEDMAS in the opposite direction, okay? Reverse BEDMAS. So the first thing that you want to get rid of, if you have any addition or subtraction. And you see that I have this addition of 200 here. I'm going to bring it over as a subtraction. So it's going to be 400 minus 200 equals to 2 pi r. So that's going to be 200 equals to 2 pi r. Now I want to solve for r, and I want to isolate this. I have 2 pi multiplied by the r. So what is that 2 pi? 2 pi is 2 times 3.1415, right? So 2 pi, I can find that, and I can, so that would be like 6.283, okay? So you want to find that first? Sure, go ahead, that's fine. You don't want to find it first, that's fine. As long as you're not making the mathematical errors of when you're bringing it over, you're dividing by 2 pi, make sure you put it in a bracket. Anyway, so what I did here is I found what 2 pi is. 2 pi is 6.283. Now, because it's a multiplication by r, when I bring it over, I bring it as a division. So it's going to be 200 divided by the 6.283, and that's going to be my radius. And that's going to be 31.8. And that is going to be a centimeter. And that would be my final answer. Okay. Now, what I'm going to leave you with, I'm going to leave you with the last question. I'm not going to do that. I want you to try it. I want you to rearrange the formula to isolate for M, rearrange the formula to isolate for V. So there's no numbers. They'll just want you to isolate, okay? Try them. Make sure that you know, you check your answer at the bottom, and then if they give you, and check your answer by pressing this. All right. Hope that was helpful, not too long.